Everywhere you look online, you're hit with a wall of noise about cryptocurrency and digital assets. It's loud, it's chaotic, and if you're not already invested, it induces some serious FOMO. But if we tune out the buzzwords for a second, this entire conversation boils down to one very old human problem: how we establish trust to move value from one person to another. Look at this printing press. For centuries, our answer to the trust problem was physical centralization. We relied on a few massive, heavily guarded governments and institutions to create money and dictate what it was worth. Even as we transitioned from trading physical cash to swiping plastic cards, the underlying structure didn't change. We simply outsourced that institutional trust to a handful of major banks and credit companies. Then, 2020 happened. A global pandemic forced almost every aspect of daily life, commerce, and human interaction to migrate onto the internet almost overnight. As physical city centers emptied out, all those legacy systems of trust were suddenly strained by a purely digital world. The vulnerability of moving our old systems online is that they still rely on a central server, a single game master controlling the board. If that server goes down or gets hacked, everything freezes. We suddenly found ourselves with a global digital economy that urgently required a new way to verify information, a network where trust couldn't be compromised or controlled by any single entity. That specific problem is what blockchain was designed to solve. Think of it like a massive online co-op game where everyone plays on the same map, but there is no game master pulling the strings. Instead of a central server verifying everyone's moves, every single participant holds an identical, constantly updating copy of a master rulebook. We call these participants nodes, individual computers that independently check the data. When someone makes a move, that action is recorded on a permanent, visible page of transactions, a block. Once verified, that block snaps into a chronological, rigid sequence, forming the chain, locking past history. But before adding it, the majority of the network must mathematically agree, a rule called consensus. By combining thousands of independent nodes, sequential blocks, and strict consensus, the network creates a mathematical environment where cheating, unauthorized editing, or system manipulation is mathematically impossible. Cryptocurrency is simply the first native application built to run on top of this decentralized architecture. It allows a person in one country to send digital money to someone across the globe in seconds, completely bypassing traditional bank fees and international holding periods. We saw the raw, unpredictable power of this during the internet meme era. Community-driven jokes like Dogecoin rapidly evolved into highly traded assets purely because a decentralized network of users agreed they had value. The market itself remains incredibly volatile, packed with sudden crashes and highly speculative tokens. Yet even when individual coins plummet in value, the underlying mathematical network continues to process every transaction flawlessly. Cryptocurrency proved that a global, decentralized trust network can operate securely at scale, regardless of whether individual tokens make people rich. Because the network excels at proving absolute ownership without a middleman, engineers are actively adopting it for industries far removed from finance. Global supply chains use the technology to track physical goods. They can pinpoint a bag of sustainable coffee or sensitive lab equipment at every step from origin to the consumer, making theft and fraud exceptionally difficult. When applied to digital voting, each ballot functions as an unalterable block. This structure allows independent verification of results while securing elections against tampered or duplicate entries. We're also seeing the rise of smart contracts, digital agreements that execute automatically. A hospital could use them to instantly transfer medical records to a specialist, but only when strict privacy conditions are met. Engineers are now deploying this code to update the slow, paper-heavy systems that historically managed our global trade and civic records. A complete shift to a fully decentralized, crypto-only global economy is unlikely to happen overnight. Governments and central banks are developing central bank digital currencies, or CBDCs. These aim to merge the technological speed of crypto with the centralized authority of traditional money. We are prepared for this transition. Years of relying on contactless tap-to-pay and mobile wallets have trained the public to view physical cash as optional. What we are moving toward is a hybrid system: Fully decentralized networks like Bitcoin will operate directly alongside highly regulated, government-controlled digital currencies. As our identities, records, and finances migrate to a purely digital state, we are left with a critical choice. The technology works, but we have to decide who we trust to hold the master rulebook.